This video is going to have a look at how do we calculate the area of a triangle if we don't know the base and the height, but we do know two sides and an angle. So having a look, we start off with our triangle and we have labelled the sides of our triangle B, we've labelled the side C, and then we've labelled our third side A. So our three sides are labelled A, B and C, and then our three corners, our three angles are labelled A, B and C, but we've used a capital letter for those labels. So normally to find the area of a triangle, we would use the area of the triangle is base times height divided by 2. When we've got a triangle like what is shown, we don't know the height of the triangle because the height of the triangle would be from the tip down to the base of the triangle. So we don't know what the height of our triangle is going to be. So we can't use our standard formula. But what we can do is if we know what one of our angles are, we can work out what is the height of the triangle and then use that to be able to work out the area. So for example, if I know what my angle is down in A, then I can work out what the height of the triangle is going to be. And that is worked out using trigonometry. So as we know, trigonometry is based on right angled triangles. And when I add in the line that represents the height, what I do is I'm forming two right angled triangles. So then I can use those right angled triangles to be able to calculate what the height is and what the area is going to be. So looking at the triangle, if I know A, then I've formed a right angle triangle, and within that right angle triangle I know that I've got H, which is the opposite side, and I've got C, which is the hypotenuse. So I've got opposite and hypotenuse, so I can use sine to be able to work out what is the height of that right angle triangle, which will be the height of my original triangle. So if I was to work out using sine what the height is going to be, I would start off using my formula. So sine of the angle is going to equal opposite over hypotenuse. So this time substituting in the values. So sine of A is going to equal the hypotenuse over C. So to get H by itself, because I'm trying to find the height of my triangle, I'm going to multiply both sides by C. So then I come to an equation that gives me the height is going to equal C times sine A. So if I know what C is and I know what A is, I'll then be able to work out the height of my triangle. So what I do is I take my known value of A, which is going to be C times sine of capital A, sine of the angle, and I can substitute it into my original area formula instead of the height value. So my updated formula is area is going to equal to 1/2, because that's the same as dividing by 2. So 1/2 of the base times my C value in my original diagram times sine A. So that then becomes the formula for the area of a triangle when I don't know the height, but I do know one of the angles. Because what I've done is I've replaced my unknown height with an expression I've used using trigonometry to work out the value of height. Now this new formula that I've created, the area equals 1/2 of BC times sine A, is going to be the formula that appears on your formula sheet. So in an exam, you'd be able to go to your formula sheet and copy that formula and be able to use it. You just need to be able to make sure that you can apply the formula. So you don't need to remember it, you just need to know how to apply it. So let's look at an example of how we can apply that formula to find the area of a triangle. So in my example, I want to calculate the area of the triangle, and I can see that I've got one side which is 4, I've got one side which is 7, and I've got the angle in between those two sides is 68 degrees. So that will now enable me to calculate the area based on those three pieces of information. So the formula that I'm going to use and remember you can use your formula sheet to identify this formula. Area is equal to 1/2 of BC times sine A. So having a look at being able to identify those values from the triangle, and my 4 meters down the bottom, I'm going to identify as my B side. Meters along the side is going to be my C side. Then my A value is going to be 68 degrees. So B is going to be 4, C is going to be 7, and my capital A is going to be 68 degrees. Now to use the formula, what we need is that the angle and then the sides have to be adjacent to each other. So here I've got 7 and 4, and then the angle in between is 68. So I can use that formula. If it was different and I had my 4 and my 7, but I had the angle over this side of the triangle, I would not be able to use my formula. So I want to be able to use it because when I go and add the height line in, then the angle, then I don't know what the hypotenuse of that triangle that I've formed is going to be. So to be able to use it, I need to make sure that I have got the angle that's in between the two sides that I know. I cannot use the formula unless I have got that angle in between the two sides. So now what I can do is, after I've completed the formula, I can go ahead and substitute in my values. So my area is going to be 1/2 times 4 times 7 times sine 68. And after I've got that written down, what I can do is go ahead and put that into my calculator to be able to get an answer. So when I do that, it is going to equal to 12.98 meters squared. So we only need the 3 lines of working when we are doing these questions. The first line is going to be the formula, second line is substitute in the values, third line is going to be the answer. That is all you need to show. You'll be able to do the sum on your calculator and write down the answer once you have put in those 2 first lines of working. So that is an example of how we can find the area of a triangle without the height using trigonometry.